Hi, I'm Travis Connor, and this is Lab 5, Choose Your Own Adventure. In this lab, I decided to observe the influence of conservation of momentum in a perfectly elastic collision involving two balls. To do this, I made a computational model to model the situation, because in a perfectly inelastic collision, no kinetic energy is lost. The purpose of this experiment was to find the new momentum of both a red and blue ball after they collide. The fundamental principles used in this lab were Newton's second law, where force is equal to mass times acceleration, Newton's second law that states that there is an equal and opposite reaction for every action, and the momentum principle. The main result of this lab was that the final momentum of the red ball was negative 0.1 kilograms meters per second, and the final momentum of the blue ball was 0.4 kilograms meters per second. The main physics ideas used in this experiment were that the net force of the situation was zero, and the change in the net force was also zero. Additionally, the force of 1 on 2 is equal to the force of 2 on 1, meaning that there are equal and opposite reactions. In this situation, the balls act upon each other like a spring force. Furthermore, the net force is equal to the change in momentum over the change in time. Corresponding to this is the momentum update formula. In this situation, the system was the two balls and the surroundings was nothing. The initial conditions for the situation was that the red ball started at negative 1 meter in the negative x direction, had a mass of 0.3 kilograms, had a velocity of 1 meters per second in the positive x direction, and a momentum of 0.3 kilograms meters per second. The blue ball started at the origin, had a mass of 0.6 kilograms, no velocity, and no momentum. Both balls had a spring constant of 10. This was to allow the force to transfer between the two balls. Also, both balls had a radius of 1. Now, moving on to the code. First, we can see the mass of the two balls. Then we can see the spring constant used later. Then we can see the initial momentum of each ball. Next, we can see the forces acting on the balls when they collide. The lines of code essentially say that if the distance between the two balls becomes less than twice the radius of one ball, a spring force will act on both balls, with one force being the equal and opposite of the other. After that, the momentum update lines for each ball can be seen, and below that is the position update for each ball. Here's the actual interaction between the two balls that can be seen. Now we can see the results of the collision. The momentum of the red ball went from 0.3 kilograms meters per second to negative 0.1 kilograms meters per second, and the momentum of the blue ball went from 0 kilograms meters per second to 0.4 kilograms meters per second. Was momentum conserved in this interaction? Using the conservation of linear momentum equation, we can see that the momentum is conserved in this collision, meaning that the situation followed Newton's second law. You can see below the math used to derive this. What will happen to the final momentum of both balls if the mass of the red ball is equal to the mass of the blue ball? If the mass of the red ball changes to 0.6 kilograms, all the momentum from the red ball will be transferred to the blue ball, changing the momentum from 0 to 0.6 kilograms meters per second, and the momentum of the red ball will become 0, and the ball will remain stationary. Here, the situation can be seen. Thanks for watching.